This is Algebra 1, Lesson 10-1. Today's date is Monday, March 30th, 3/30, 2020. This is our new unit, 10-1, Intro to Parabolas. Because it's a new unit, you should see that there's a new unit guide and a pacing guide up. Every lesson should have one corresponding homework assignment and only one. Our objective today is to use vocabulary of parabolas to find x-coordinates of the x-coordinates of the vertex. All right, so there's a bit of vocab when it comes to parabolas. Some of these will be review, some of them will be new. The first thing that you see is this is the shape of a parabola. A parabola can have one of two shapes. It can either be a smiley face or it can be a rainbow. That is very informal. This one is a smiley face. Another way of saying that, mathematicians use the word, this opens up. So we're going to draw a line in the middle eventually. So I'm going to put opens up a little bit to the left. This opens up. And if I can come over here and I can do a parabola that faces the other way. This I consider to be a rainbow, and this opens down. The next thing that we can talk about is this axis of symmetry that I was about to draw. Let's go ahead and make that now. So the axis of symmetry is a line that cuts this parabola in half such that the left side and the right side are symmetric. If I were to fold the paper on this line, then the curve of this parabola would match up with the curve of the other side. So I'm calling this the axis. Oh, my computer lagged there. Axis of symmetry. I cannot spell. And I'll do arrows. That is the axis of symmetry. What else do we have? These are things that we do already know, like this right here. That's called the y-intercept, because it's the point that this parabola touches the y-axis. And it's a cool question to ask. How many y-intercepts could you possibly have with this curvy type of parabola shape? And the answer, hopefully, you'll think is 1. It's impossible unless the parabola is somehow flipping this way, which we're not going to talk about in Algebra 1. I don't even think we talk about that until maybe the end of Algebra 2 or the beginning of pre-calculus. Next, we have some x-intercepts. So these down here are our x-intercepts. So we'll say x-intercepts. And do arrows to both of those points. By the way, I guess we should be listing the coordinates of each of these points too. It would help us out later. The coordinates of our y-intercept, the x value is always 0 because I don't move left or right, and then I go up 7, so 0, 7. Our x-intercepts, I'm going to guess here because it's not 100% correct. I'm going to guess about negative 1.5, negative 1.5, 0. And I'm going to guess negative 4.5, negative 4.5, 0. Just some guesstimates. The other point that we want to talk about is the vertex. It's probably the most important point when you're talking about parabolas. It's like the tip, the very end of the parabola. Where does it turn around? So that is called the vertex. And the vertex is obviously special because if I move the vertex left or right, it'll move the entire graph left or right. You need the vertex to graph a parabola, or you need two x-intercepts to graph a parabola. The vertex and any other point will always graph it, or two x-intercepts. I'm trying to think if there's anything else. I think those are the only two options, because if I give you 2 points, you don't know if it turns around there, if it keeps going through there, logically. So that's all I have for vocabulary, and let's also practice finding the vertex, the second part of our objective today. If the x-coordinates are 1 and 7, what is the x-coordinate of the vertex? And we want to think about this logically. Like if I just showed you this graph up here, and you could probably do it on your own if I extended out the x-axis a little bit more. How would you find that? Well, to find the x-coordinate of this vertex, what you can do is you can take the average of your x-intercepts. Another way of saying that is your vertex 100% of the time will always lie between your x-intercepts, exactly in between them, if you have x-intercepts. So this distance right here is the same as this distance right here. That's the key giveaway. And we're only asking for the x-coordinate. I don't care what the y-coordinate is. Again, if I can check that mathematically. I know I'm kind of doing longer notes than I need to here, but if I do negative 1.5 and negative 4.5, if I add those together, I can do some scratch work. Negative 4.5, and I add a negative 1.5. That adds up to negative 6. Okay, if I divide that by 2, because I'm taking the average, negative 6 divided by 2 is equal to negative 3. And check it out, the x-coordinate of the vertex is negative 3. So in order to find the vertex down here, and the general way that you find the vertex is you want to think about it as the average of the x-intercepts. There's a C in there somewhere, of the x-intercepts. And I'm being very, very informal by saying this. I should technically be saying it's the average of the x-coordinates of the x-intercepts, but it doesn't make sense to take the average of the y-coordinates because the average is always going to be 0. So another way of saying this is you can do x1 plus x2, those x-coordinates, and then divide by 2. That's what it means to take the average. So in our case, we're going to be taking 7 and we add 1. So in our case, we're going to say, what is, I guess, 1 plus 7, and then divide by 2. That's going to be 8 divided by 2, and therefore the x-coordinate is 4. I'm pretty sure we could have gotten that without having any formula, but there it is. I know some of you really like formulas, and that concludes Notes 10-1. I'll see you guys tomorrow.